let me proceed with this one. The structure of what you call as magnetron oscillator. We have finally concluded that higher the magnetic field, less the number of electrons that will be passing from cathode to anode. Okay. So one of the important things that we have to keep in mind is velocity modulation. So I will write that one. Important thing that you have to keep in mind. Important thing, that is velocity modulation. Okay. So a magnetic force happening on electron, that is nothing but, in general we can quote magnetic force happening on electron, that creates the velocity modulation. I can, in general I can write like that, right? How it is happening, that is my question. Question is how it is happening. One minute. Okay, how it is happening. Okay. Okay. Anyway, so I will tell, higher the RF input, higher the RF input, higher the magnetic field, higher the magnetic field, and higher the magnetic field, less number of electrons will transfer, and higher the magnetic field, less number of electrons will transfer. Okay. So if magnetic force is more, in that case velocity is more. If magnetic force is more, in that case velocity is more. Okay. Similarly, if magnetic force is less, in that case what? In that case velocity is less. Okay. So these two important things we have to keep in mind. Okay. So in that case, because of higher velocity, what happens? The lead electron will bunches with the reference electron. Because of higher velocity, lead electron will bunches with the reference electron. Okay. So because of variable magnetic field, velocity of electron is also variable. So what happens means, early electron having lower velocity and lead electron having higher velocity. So electron bunches occurs. Because of electron bunching, there will be magnification or amplification of RF signal, which is over the inserting over what you call as in anode cavity. So electron bunches occurs in near the what you call as interaction space. Okay. So that is happening in the inside the magnetron oscillator. So I will write that one. What I had, because of higher velocity, a lead electron will bunch with the reference electrons, and because of variable magnetic field, and because of variable magnetic, I will write it magnetic force. Because of variable magnetic force, what happens? Velocity of electron is variable. Okay, and early electron having lower velocity, early electron having lower velocity and lead electron having higher velocity will have higher, early electron having lower velocity and lead electron having higher velocity, having higher velocity. So what happens? Electron will bunch. Okay, because of electron bunching, because of electron bunching, so what happens? Magnification, you can call this as amplification, something like that. Okay, of RF signal, of RF signal which is inserting over, otherwise it is enough, it is inserting over the what you call as interaction chamber, that is not required. Okay, so because of electron bunching, so magnification of RF signal occurs. Okay, so this is what I had to discuss you, and the figure related to the things what I have explained to you is, I will just 1 minute, just bring this down, is this two figure, you can see that one is the figure A and figure B. Okay, so in this figure you can see that electron, straight electron A, when magnetic field is slightly less, B, C and D. D it comes back to the, it will touch to the anode plate, anode pole, but E, in this case it will come back to the cathode itself. Okay, like that. So that mainly depends upon the amount of magnetic field that we are applying to the through the RF input signal. Okay, so what happens? These things becomes the electron bunching. Electron bunching, and it will be moved in this manner. Okay, I think this too clear for you people. I will write just like the internal circuit of what you called as magnetron oscillator. Internal circuit of magnetron. Okay, so in general this figure indicates the internal structure of magnetron. Okay, so this acts as a inductor, this is nothing but the capacitor. Okay, so in general I can draw just like this, a two parallel plate capacitor. Okay, with that is being given like this to an inductor. Okay, it is clear for you. So this acts as a inductor and this acts as an what is called as capacitor. So normally it will be in this form. resonance circuit like this. So the resonant frequency will be Fr is nothing but 1 by 2 pi root of Lc in case of magnetron oscillator. Okay, keep in mind that one. So normally it will be just, you can see that from this figure, it will be just like this. You can see that we are having like this. This is positive plate, this is negative plate, and this act as our inductor. Okay, so this is nothing but our anode cavity. Okay, so these two act as parallel plate capacitor. Now it is clear for you. Okay, the current can, okay. So let me see some of the advantage of magnetron oscillator. The first advantage, it is a high power microwave generator. High power microwave generator. Okay. Second, with the antenna, it can be easily installed. Okay. The third one is widely used in spacecraft. It is widely used in spacecraft. It is an efficient device. Compared to klystron. Because efficiency is high. Mainly it is being utilized in radar application. Okay. And some of the disadvantage I will explain here of the magnetron oscillator. First one is a costly device. Second one, it cannot be tuned to wide range of frequency. Cannot tune to, it cannot be tuned to wide range of frequency. Okay. Then the third one is resonance is based on dimension and it is fixed. Okay. Resonance is based on, resonance is fixed and resonance maybe depends on dimension. Okay. And always it is being fixed one. Keep in mind. And okay, that is resonance. Resonance is based on dimension and it is fixed. Okay. The next point is phase stability is poor. Phase stability is poor in case of magnetron oscillator. So I will give you some of the specification of magnetron in general case. That is, first one is peak power. It can have a peak power of 3 kilowatt to 4 watt. DC voltage of 50 volt, average power 800 kilowatt, efficiency 40 to 70%. Okay, these are some of the specification of magnetron oscillator. Okay, so in general, I have discussed the operational stage. I will give you the general conclusion of this video. That is operational step. First, what we have taken, it is nothing but the generation of electron from cathode. Cathode is nothing but generating the electron. Okay. Second one, well, after that, it is not, what is happening? Velocity modulation. It is nothing but general conclusion. Okay, velocity modulation, that gives the magnetic force Fp, which is nothing but Q into V cross B, that is by magnetic force. Next point is formation of electron bunching. Formation of electron bunch, that is okay, what happens, reducing, and it is nothing but transfer of energy. I will write transfer of, at that time what is happening, transfer of energy, or reducing and reducing. Reducing in the sense means transferring means electron bunching. Okay, I think it is enough. Formation of electron bunch, that is nothing but transfer of energy. Okay, so this is the some of the conclusion related to what I have explained in the structure of magnetron oscillator. I think it is clear for you people. Just verify the things, study it, and write the things what I have explained here. Thank you for watching this video. Okay.